All right, let's now talk about how we can use these optimization algorithms in Python. And I can promise you this is going to be a very short video because it's super simple to do in PyTorch. So the most common optimization algorithms are still SGD, the regular SGD with momentum, and Adam. There are, of course, other optimization algorithms, and I will mention some of them in the next video. But these two are usually the ones that most people use in practice. And if you are also interested in using other types and exploring them, you can also find them here under this website. And there's also a more detailed description of the parameters that we can use. So how we use them? We have already used Optim SGD before in previous code examples and in the homework, I think. So right now the only difference is really that here I added the momentum term to it. Usually I find that using a learning rate of 0.01 or 0.001 works well, but you have of course to experiment with it. It really depends on the data set and weight initialization and data normalization, batch norm, and so forth. There are many things that affect finding a good learning rate, so it's something you have to try out in practice. When I use SGD, I usually also use a learning rate scheduler. I will show you or give you the code for reference later in the slides. And if I use a learning rate scheduler, I usually also use a learning rate of 0.1. For Adam, I usually don't do anything. I use usually a learning rate of 0.001 or 0.005. These usually work well for me, but again, it depends on the problem. I recommend also exploring some different learning rates, but most of the time something like 0.005 works well for me. And it's sometimes also easier to find a good learning rate with Adam compared to SGD. With SGD, I have to try out many more things to get it to work whereas with Adam, usually multiple learning rates can work well in practice. So if you're using any of these, like the momentum or Adam versions, also the momentum version of SGD or Adam, then and you want to save your model for continuing training later on, you also have to save and load the optimizer because there is now a given state. So there's a state for the momentum and also for the adaptive learning rate component, the RMS prop component. But I talked about saving and loading optimizers in an earlier videos. I think it was like 2 or 3 videos ago. So if you work with the momentum version or the Adam and you want to continue training at a later time point, make sure you know how to save and load the optimizer states too. So just a little bit more about Adam. So in the previous video I showed you that there are 2 parameters. So the alpha parameter for the momentum term and the beta parameter for the RMS prop term. They are also available to modify in the Adam optimizer. So here they are both called betas, like in the paper. So this would be beta 1, and this one would be beta 1, 2. And this one would be then beta 2 and beta 2. So just so you know what they mean. So the first value is for the momentum beta and the second value is for the RMS prop beta. Personally, I never change these. It usually works well for me just keeping them as they are by default. And also in many papers, when you read deep learning papers, almost no one changes these parameters. They always say they use the default parameters because they usually work pretty well in practice. Here are 2 examples of using these different optimization algorithms. So here I was using an SGD with a learning rate scheduler, halving the learning rate when it plateaus, and also a momentum term of 0.9. So the momentum term here was 0.9, the learning rate was 0.1, and it was halved every time the validation accuracy was plateauing when it was not improving. So it was fluctuating, and then I was halving the learning rate to stabilize the training. So that's then more like the fine-tuning stage. And you can see in the beginning it's rather noisy, and then probably after this halving it stabilizes more because there's no improvement anymore. So we can halve the learning rate and then remove that oscillation. So that's what I was doing here. And with this setup I reached test accuracy of 97.34%. On the right hand side I was just using Adam with default parameters. I think I used a learning rate of 0.005 here. And I got also essentially the identical performance. But you can see, because we are not using the learning scheduler here, probably we see it's a little bit noisy here around that region. But to be honest, both work perfectly fine in practice. And I find usually Adam works a little bit better for me, but I'm also a very impatient person. I think if I would toy around with the SGD more, I could probably also get a similar good performance or even outperform it. But Adam is something, if you are lazy like me, it usually always works pretty well, and I kind of like it for that reason. So in the next video, I want to just briefly go over some, I would say, more advanced concepts regarding optimization algorithms. I won't talk about them in detail. I just want to mention them, like giving you references for future study if you're interested.